Hello friends, welcome to my channel. Here today we're gonna discuss about superposition of two collinear harmonic oscillations having same frequency. Okay, so this is third lecture of wave and optics. I'm Lekajit Oza, and if you want to follow me on Insta, this is my Insta ID Oza Lekajit 123, right? So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. So now let's start the topic. So we're gonna discuss two different cases. Okay, in this video we're gonna discuss one case, that is, superposition of linear harmonic oscillations having same frequency. Okay, in the next video, in the next lecture, I'm gonna discuss about superposition of collinear harmonic oscillations having different frequencies. Okay, so here you see, suppose we have two harmonic oscillations. Let me consider the displacement equations of two harmonic oscillations. Let us suppose displacement equations of two collinear harmonic oscillations be y1 and y2. Suppose y1 is equal to amplitude a1 sine angular frequency omega t. Omega is the angular frequency, okay, and phase constant is phi 1, right? And let me consider y2 is equal to amplitude a2 sine having same frequency. So let me consider again omega t plus phase constant is suppose phi 2. Let me take that way, right? Now according to the superposition principle, according to the superposition principle, the resultant displacement is given by y is equal to y1 plus y2, right? So now let us add these two above equations. Then in order to obtain the resultant displacement, then here we're going to have this, and then y2 is equal to this one. Here you see y1 plus y2, right? So now here we're going to expand these two using sine a plus b formula. So if we expand here a1 sine a, use sine a plus b formula here. So sine a, that is sine omega t, cos b means cos phi 1 here, and plus cos a, that is cos omega t sine phi. Sine b is sine phi 1 here. Then similarly a2 sine omega t cos phi 2 plus cos omega t sine phi 2. That's what we're gonna have. So now let me open the brackets. Then what we're gonna get, then here you see this gonna be equal to here a1 should be multiplied with this one as well on opening this bracket. So now let me remove this bracket as well. Okay, so let me remove these brackets. If we remove these brackets, then a2 should be multiplied with the both terms in the bracket, right? So here we must write a2. Okay, so then what we can do here, what are the terms that can be those can be taken common. Here you can see, here we have sine omega t, here also we have sine omega t, right? If we take sine omega t common, then within bracket we're gonna end up getting a1 cos phi 1, right? Then here we're gonna have a2 cos phi 2, right? Plus then similarly if you take cos omega t common, then what you're gonna have, cos omega t common, then within bracket we're gonna end up getting a1 sine phi 1 and a2 sine phi 2, right? So a1 sine phi 1 plus a2 sine phi 2, right? Sorry, just okay, sine phi 2, that's what we're gonna have, right? Now you see, now let us consider this part as a cos phi, and let us take this phi as a sine phi. Okay, so let me write here, let a cos phi is equal to this, just wait, let me copy this, is equal to this one is cos phi, a cos phi. Okay, so a is the resultant amplitude. Okay, then a sine phi is equal to this, that's going to be equal to, right, let me copy this here, this is what we're going to have, right? Okay, if you consider these two, then this above equation y is equal to this becomes y is equal to, instead of this we're going to put this, and instead of this we're going to put this. So doing so, we're going to have sine omega t, and let me write this a cos phi, so let me write the a here, then cos phi plus, so if you replace this by this one, let me write the a first, then cos omega t sine phi, that's what we're gonna have, right? So now you see, if a is taken common, then within bracket sine omega t cos phi plus cos omega t sine phi. Now here you can see this is sine a cos b cos a sine b, that means sine a plus b. So that's why, let me take another slide, let me take a new slide, let me copy this last step and let me go to a new slide. Okay, just give me a second. So here you see, this is the last step we have got. Now a sine a plus b, here a is omega t and b is phi, so b is phi. So this is the resultant displacement. Okay, resultant displacement due to the superposition of two waves y1 and y2. Okay, so now let's find the value of a and phi. Okay, how to find that? So let me go back to the previous slide. Here you see, let me take, this is equation number 1, and let me take this is equation number 2. Now let me copy these two equations and let me paste this in the new slide. Okay, so here is the equation 1 that we have considered, and here is the equation number 2. Just give me a second, just wait. Okay, done. This is the equation number 2. So squaring and adding these two equations, okay, squaring equation number 1 and equation number 2, then adding, then what we're gonna have, a square, cos square phi plus, on the left hand side you're gonna have a square cos square phi, then a square sine square phi, right? On the right hand side, take the right hand side of this equation number 1, then square it, whole square, then whole square of the right hand side of the equation number 2. So that's gonna be this, right? That's what we're gonna have. Now here you see, from these two we can take a square common. On taking a square common, we're gonna get this term. This is gonna be like this, So right, and this is equal to nothing but 1. Sine square phi plus cos square phi, that's going to be 1. So we can write a square is equal to, now let me expand this. Okay, just give me a second. So let me write this one towards this. Okay, now let us expand these two. Okay, then what we're gonna have, we're gonna have a1 square cos square phi 1 plus a2 square cos square phi 2 plus 2a1 a2 cos phi 1 cos phi 2. Right, here we have applied a plus b whole square formula. Similarly here also we're gonna have a1 square sine square phi 1, then a2 square sine square phi 2, then plus 2a1 a2 sine phi 1 sine phi 2. That's what we're gonna have. Right, now you see, if you observe carefully, then if you take this a square and a square common, then within bracket we're gonna get cos square phi 1 sine square phi 1, and sine square phi 1 plus cos square phi 1, that's gonna be 1. So here we're gonna have a1 square plus, then again if you take a2 and a2 square common, then on taking these two common, within bracket we're gonna have cos square phi 2 sine square phi 2, which is gonna be equal to 1. So 1 into a square a2 square, that's gonna be a2 square. Right, and then let us take 2a1 a2 common, then 2a1 a2 common, then within bracket we have got cos phi 1 cos phi 2, cos phi 1 plus into cos phi 2, then plus sin phi 1 sin phi 2, sin phi 1 sin phi 2. So here you see cos phi 1 cos phi 2 sin phi 1 sin phi 2. This is cos a minus b formula. You can use the identity of trigonometry. So that's going to be cos phi 1 cos phi 1 minus phi 2. Right, here a1 square plus a2 square plus 2a1 a2. So that's going to be cos phi 1 minus phi 2. So this is the resultant amplitude. If you remove this square, then here we have to put a square root. So this is the resultant amplitude. Right, so now let's find this phi. Okay, so again, if we divide equation number 2 by equation number 1, so let me copy these two equations and let me take a new slide. Okay, so these are the two equations. Okay, equation number 2 divided by equation number 1, then a sin phi by a cos phi, that's going to be equal to a1 sin phi 1 plus a2 sin phi 2 by a1 cos phi 1 plus a2 cos phi 2. Right, here you see a cancels, so we're gonna have 10 phi is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. That means phi gonna be 10 inverse of this, right? Okay, that's why phi, that's gonna be equal to 10 inverse of this. Just wait. Right, so hope you have understood this. So hope you have understood this lecture. So if you like this lecture, please do subscribe the channel, also hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Thank you for watching. See you in the next video. Bye bye.